Today I'll be deriving the John Leonard Keynes formula for the multiplier when you reduce taxes by some amount. So let's begin with saying MPC plus MPS equals 1. All right. Let me stretch. All right, okay. All right. So when we reduce taxes by some amount, that's like the same effect as giving people money. However, the only difference is that when you lower taxes, the first round spent would be MPC. So let's say you lower taxes by an aggregate amount of D. So lower taxes by D dollars. And D could be 8 billion or 20 billion. If you lower taxes by a total amount of D dollars, that means people have D dollars amount to spend. D dollars more money to spend. All right. However, unlike the previous video, this D will not be exactly D. The first round spent would actually be D times MPC. Because you're in a scenario where government is giving out money, the GDP increases by D first because the government doesn't save. However, if you lower taxes by D, then then the first round spent would be D times MPC because the people are saving D times MPS. So it would be D times MPC. So let me write the change in GDP equals that plus, and then DMPC squared plus DMPC cubed, and so forth, all the way to DMPCN, limit as n approaches infinity, because we're going to assume that there's multiple spending rounds. So this money goes to one person, this one person will spend it, and will save some of it, so we'll spend it and save someone, and this goes infinite amount of times. And similar to my previous video, I'm going to multiply both sides by MPC. So MPC, change in GDP, would equal D. If I multiply this by MPC, I need to multiply the right by MPC. So MPC squared plus D MPC cubed plus D MPCN plus 1. Okay. Now let's subtract these two. So MPC, change in GDP, equals, well, I want you to notice here that when we subtract these two, this will cancel out with that because they're equal to each other. This will cancel out with that, and this will cancel out with something in here. So the only terms that remain is D MPC n plus 1 minus D MPC. Okay? These are the only terms that remain because all the other terms get canceled out. Even this term, because there's a D MPC n here by, logic. All right, sorry about that. And so we have this. So let's factor out change in GDP to get MPC minus 1 equals, and let's factor out DMPC to get this. Sorry about that. MPC times n minus 1. All right. Factor out DMPC, and by exponent rule, we subtract 1 when we factor out MPC, and when we factor out DMPC from here, it just becomes 1. That means the change in GDP equals DMPC over MPCN minus 1 over MPC minus 1, lim as n approaches infinity. But look, I want you to notice something. MPC, we can assume to be less than 1 and greater than 0. Now, any number less than 1 and greater than 0 to infinite power would equal 0. So let's take a 0.9, for instance. So 0.9 times 0.9 would be 0.81. 0.9 times 0.81 would be 0.729. And you can see that it's getting smaller and smaller. Let me, in fact, think about this. 0.6561, and this number is getting smaller and smaller, and it will approach 0. So any number in between 1 and 0 to infinite power would equal 0. So lim as n approaches infinity, this just becomes 0. So change in GDP would equal dMPC times 0 minus 1. This just becomes 0 because MPC to infinity, and MPC is in between 1 and 0. It just becomes 0. So MPC minus 1 equals negative dMPC over MPC minus 1 equals dMPC 1 minus MPC. All right? Now look at what we said above here. We said MPC plus MPS equal 1. That means if we bring this to the left side, if we bring this to the right side, MPS equals 1 minus MPC. So if we look here, this just equals dMPC MPS, because 1 minus MPC equal MPS. And finally, this just equals the change in GDP. So this is the change in GDP if we lower the taxes by some amount, D. And the multiplier, you can see here, is MPC over MPS. Thank you.